In this video, we're going to write a Python program to determine if two strings are anagrams to each other. So given two strings A and B, return true if A is an anagram of B and false otherwise. So just for recap, what exactly is an anagram? It is a word or phrase that can be formed by rearranging the letters of the other word or phrase. So for example, we have car and arc. So we can rearrange the word car to get arc. If there's a C over here, then there has to be a C over here. Listen and silent, basically also anagrams, and knee and keen. Now, one thing to note is that if over here, if there are two E's over here, then there must be two E's on the other word. So the number of frequencies must also be the same. So one way to determine if two words are anagrams is to take them and sort the letters, just like sorting numbers from least to greatest. So after we sort them, we both get E, I, L, and ST, and this indicates that silent and listen are anagrams. Let's take a look at the Python code. So we have the string A and B. We're going to lowercase both of them, so that's the lower function. And then we're going to also sort the letters. And we compare them. If they are the same, we return true. If not, we return false. And you can use these two for testing. So this one should return true, and this one should return false. And also this code is O n log n because we use the sort function. What if I tell you that there is a better and faster solution than the previous one? Well, here it is. So let's say we have feet and defeat. We then create an array of size 26, and we fill this array with zeros initially. So let's say index 0 is for A, index 1 is for B, and so on. After we created the array, we're going to go through the first word feet. So starting with F, we know that F is at index 5, so we increment by 1. How about E? Well, E is at 4, so we increment 0 to 1. E again, this becomes 2, and D, this becomes 1. Now we go through the second word. So starting with D, D is at index 3, so we decrement, we minus now. So this becomes 0. How about E? 2 becomes 1 here. For F, 1 becomes 0, and E, 1 becomes 0. You can see that all the numbers in the array are zeros, and this indicates that both of these words are anagrams. So you might be wondering, how do we know that F is at index 5? Well, that's a very good question. So here's a way to determine. We translate F into its Unicode. So the Unicode of F is 102, and we can use the OR function to do that. Then we take this number, we minus the Unicode of A, which is 97, and then we get 5. So this 5 tells us the location of F inside this array, and then we increment the 0 to a 1 if we're going through the first word. How about the letter D? Well, the Unicode of that is 100. We minus the Unicode of A, and it's always going to be A. So we get 97, and then we get 3. So the location of D is at index 3. If we're going through the first word, we will increment the 0 to a 1. Let's go through the Python code for the second solution. So first, we lowercase s1 and s2. We also determine that the number of letters in the alphabet is 26. Then we compare the two strings. If the sizes are not the same, then we have to return false because they cannot be anagrams. And this line of code will generate an array of size 26, and all the numbers in the array are zeros, and that's basically put into the count variable. Now we go through the first string, we determine the location of the letter, right? And then in the array, we increment by 1. Now we go through the second string, we determine the location of the letter in the count array, then we decrement by 1. And at the end of the day, we go through the count array and we check to see if all the numbers are 0. So if we find a number that is not 0, then we know that S1 and S2 are not anagrams. So we return false. And at the end, we know that all the numbers are 0, so we return true. And the runtime of this code is O of n because we do not use sorting, so this solution is much faster than the previous solution. And also, what is the space complexity? Well, in this code, we generate an array of size 26. So O of 26 is equal to O of 1. So the space complexity is constant. And that's basically it for today. If you found this video helpful, don't forget to subscribe and like, and also comment down below if you have any questions.